Before we start to graph two-step inequalities, let's go back and look at the skills we've already learned in two-step equations. There's very little difference between solving a two-step inequality and solving a two-step equation. In fact, the only difference in the two skills happens when you either multiply or divide by a negative value. To solve a two-step equation, we're going to follow these steps. First, ask yourself, what is happening to the variable? This is the same question we start with every single equation, one step, two step, etc. List both operations in order, using the order of operations. We have 3x minus 5 equals 7. The first thing happening to the variable is I'm multiplying by 3, then I'm subtracting 5. I need to undo those operations using the inverse operation. So now I ask, how do I undo the operations? Write the inverse operation for each operation, each of the current operations, and we need to write them in inverse order. So we multiplied by 3 and subtracted by 5. So to undo that, we need to add 5 and then divide by 3. We started going from the bottom up, now we're going from the top down using inverse operations. I'm going to apply the first inverse operation to both sides of the equation. Add 5 to both sides to keep that equation balanced. Negative 5 plus 5 is 0. When I evaluate each side of the equation, I need to check that. I check for my identity. So I get 0 on the left side, leaving with 3x. 7 plus 5 is 12. Now I'm going to apply the second inverse operation and evaluate again. So I'm going to divide both sides by 3. 3x divided by 3 is just x. I got my identity. 12 divided by 3 is 4, so x equals 4. I could check this equation by plugging the solution back in and checking for a true statement. Let's try a couple problems. The first one, I am dividing by 5, then subtracting 5. Even though it's negative 5 plus x over 5, I can read that as minus 5. I could rewrite this equation as x divided by 5 minus 5. So I'm dividing by 5, and then I'm subtracting 5. How do I undo this? I add 5 and multiply by 5. Add 5 to both sides. I get my identity on the left because negative 5 plus 5 is 0. So I'm left with just x divided by 5 on the left and 7 on the right. Next, I'm going to multiply both sides by 5. X divided by 5 times 5 cancels out, giving us our identity of 1 times x. 7 times 5 is 35, so my solution is x equals 35. On your own, try the next problem. You can use the arrows if you need them, but again, that's training a mental process. It's showing you how to put those values in order and the operations in order. If you can do this mentally, great. If not, try writing it out. It's a great tool. Take this inequality as it stands. This is a two-step inequality. Try graphing it. On your own, try to complete this statement below, based on your observations about trying to graph a two-step inequality. To solve a two-step inequality, we solve it the same way we would solve a two-step equation. What's happening to my variable? I'm multiplying by 2 and then subtracting 8. If I want, I can write that out. The first thing is happening, I'm multiplying by 2, then I'm subtracting 8. So to undo that, I'm going to add 8 and divide by 2. I'm going to apply those operations to both sides. Negative 8 plus 8 is 0. 2 plus 8 is 10. So 2x is greater than 10. Notice the inequality sign didn't change. All we did was change the values on either side by using inverse operations. I'm going to divide both sides by 2. 2x divided by 2 gives me just 1x. 10 divided by 2 is 5, and it's still x is greater than 5. The inequality does not change, just drops straight down. If you have to multiply or divide by a negative, that's when you need to flip the inequality symbol. So we divided here by positive 2. Had we been dividing by negative 2, for example, it would no longer be x is greater than 5, it would be x is greater than negative 5. So only if you multiply or divide by a negative value. Once we've solved the inequality and gotten x by itself, we can graph the inequality on the number line. So I'm going to go to at 5 on the number line, it's greater than but not equal to, so it's going to be an open circle, and then I can test a point to figure out which way my arrow is going to face. 0 is always a great number to check. Is 0 greater than 5? No, it's not. That's a false statement. So I'm going to point away from 0. If we got a true statement, I would have pointed at 0. Try to ignore the urge to use the shortcut. Some teachers will suggest that the inequality symbol looks like the arrowhead. Now in this case, that rule works, but that's only when the variable's on the left side. So you can either check a point very easily by looking for a true statement, or you can flip the inequality around and then look at the arrow. You're going to make more mistakes using the shortcut than just checking a point. Let's try a couple problems together. Treat the inequality like a two-step equation. I'm going to solve it by asking the same two questions. What's happening to my variable according to the order of operations? And then how do I undo that using the order of operations? I need to find my current and inverse operations. So I'm multiplying by 3, and then I'm subtracting 9. To undo that, I'm going to add 9 and divide by 3. If you still struggle with these inverse and current operations, try writing them out like this. Give you a set of instructions for how to solve this inequality. So I know that I need to add 9 to both sides, evaluate, that's going to give me 3x is greater than 13, and then I know I'm going to divide by 3. Divide both sides by 3, x is greater than 4.33. In this case, we rounded to 2 decimal places. When I plot a decimal or fraction on a number line, I need to find the two numbers that the value is going to be in between. Now this is going to be an open circle because it's just greater than, not greater than or equal to. So I need to find a value above 4.33 and a value below. It's going to be between 4 and 5. It's going to be about a third of the way past 4. So as long as I see that it's close to that, your estimation is good. So I have my point plotted. My circle is open because it's not equal to. Now I need to figure out which way the arrow is going to point. I'm going to plug a value in for x. 0 is the best option. So is 0 greater than 4.33? No, it's not. If it was, I would point at 0. Since it's not, I'm going to point away from 0. That means that all of the values to the right of this value that we've indicated, 4.33, make the statement true. 10 is greater than 4.33. 15 is greater than 4.33. 0 is not. Negative 5 is not. Negative 10 is not. Let's try this next problem. So I need to think what operations are happening to my variable. I'm dividing by negative 4. Then I'm adding 3. To undo that, I'm going to subtract 3 and multiply by negative 4. So now I have my set of instructions. Both sides, I'm going to subtract 3. That gives me my identity because 3 minus 3 is 0, leaving me with just x divided by negative 4 on the right. 6 minus 3 is 3. Now I know that I need to multiply both sides by negative 4. When I do it to the right side, it cancels out the negative 4 that we're dividing by. The left side, when I multiply negative 4 times 3, I get negative 12. Now notice, when I multiply or divide by a negative, I need to switch my inequality. It went from less than or equal to greater than or equal to. So my answer is negative 12 is greater than or equal to x. Whenever you multiply or divide by a negative value, you have to flip around that inequality symbol. Now I can plot it. So at negative 12, I'm going to put a closed circle because negative 12 is included. Negative 12 is greater than or equal to negative 12. Now I need to figure out where all of the other solutions are located by finding which way to point that arrow. 0 is always a great value to plug in, but you could try anything. Let's check negative 15. Is negative 12 greater than or equal to negative 15? Negatives can make this challenging. 12 is greater than 15, but negative 12 is not greater than negative 15. Negative 15 is smaller. A good way to remember that is the saying less is more with negatives. A bigger value or a value with a bigger absolute value will be more negative. It will be a smaller value. You can always think of negatives as money as well. If I owe $12 and I owe $15, even though I'm in debt, I would have more money. So negative 12 is still greater than negative 15. A good simple way to look at this also is that any value to the right on the number line is going to be greater. Any value to the left is going to be less than. So negative 15 is less than negative 12, where the dot is, or negative 12 is greater than negative 15 because it's on the right. There's a lot of different ways to determine if you have a true statement. Negatives make that very challenging. So now I'm going to point at negative 15 because I in fact have a true statement. On your own, try these two problems. Use the arrows if they help. Solve each two-step inequality and plot it. Remember, if you have to multiply or divide by a negative value, you need to flip the inequality symbol around. Less than becomes greater than becomes less than.